Hello everyone, welcome. This is the first lecture in your course Mastering Ansible by Avionics. My name is Ahmed, and in this section 1 of this course, we are going to discuss what Ansible is and how to install it. So first of all, let's discuss software provisioning evolution, how software used to be provisioned in the past and in the near past and currently. Long ago, there used to be a clear distinction between a software developer and a system administrator or an operator. The role of the software developer was just to test the code that the developer has written, while the role of the second was to avail the necessary infrastructure and deploy the application. And then after some bugs perhaps have been introduced, after some new requirements are made, the life cycle is repeated. The software returns to the hands of the developer to make any required changes and then hand it over to the operator or the system administrator to deploy it and to avail the necessary infrastructure, perhaps for a new environment, and so on and so forth. The life cycle continues until the software is finally released. And as time passed, technology evolved, and as a result, the number of servers that need to be managed increased significantly. Currently, we are in the age of virtualization. Actually, virtualization is not a new term here. It has been also perhaps an old one. However, it has in the past maybe 5 years evolved significantly with the advent of what was called cloud computing. The idea of launching your VM in the cloud, launching it on a platform like Amazon or Google or Microsoft Azure and all those platform providers. They provide you with infrastructure as a service. You just give them requirements through a web page, for example, and then launch an instance of your virtual machine in the cloud. Manage it the way you want, install the necessary software, do whatever coding you need, and then perhaps you can destroy it and create another one or end the whole operation. You can do whatever you want. It's just your machine in the cloud. So this is an important improvement and an important stage of evolution in software development, because now the life cycle of an application is faster than ever. And with the advent of new software methodologies like agile development, you have heard this term before, it is a form of software development where the application lifecycle is kept at the minimum. The application lifecycle should last no more than a couple of weeks, after which the application is released for testing. Testing, of course, reveals bugs or new features that need to be installed, new components that need to be incorporated into the application, so it returns back to the developer to do the necessary work and then deploy it again and over. This life cycle, or this iteration as it's sometimes called, should not last more than 2 weeks. So imagine how system administrators should be working hand in hand with developers to keep this life cycle to the minimum. To address those necessities, aiding tools arose to facilitate and shorten the application lifecycle, and a new buzzword surfaced. Perhaps you have heard it before. It's called DevOps. So what is DevOps anyway? I know you have heard this term before. Some of you may have an idea about it. Some of you may be seeing it for the first time. So for all of you, let's have a quick discussion of DevOps right before we delve into the world of Ansible. DevOps is one of the terms for which you will hear different definitions depending on whom you are asking. Just like big data and cloud computing, it's just one of those terms that have been heard frequently in the last couple of years. DevOps in its core is a concept that eliminates the difference between developers and operators, and of course hence the name. Both teams, developers and operators, should be able to use a set of tools that helps shorten the application lifecycle and ease the overall development, testing, deployment processes. DevOps tools have many categories. Let's have a quick example. You have version control like Git. We have also Bitbucket and other version control systems. Continuous integration like Jenkins. Testing like JUnit. Provisioning and configuration management like Vagrant, Chef, Puppet, Salt, and of course Ansible. So along came Ansible. Through all this buzz, through all this tools and categories, we have Ansible. So what is Ansible? If you are like me interested in the name origins, Ansible, as you have probably guessed, is not an English word. If you look at a dictionary, you find that it stands for nothing. There is no word in English that is called Ansible. But it has its roots, and these roots actually are literary ones. Ansible is a fictional device that was capable of transmitting messages at a speed faster than light. The sci-fi author who first coined it stated that it was derived from the word answerable. It was first introduced in a novel that was written in the 1960s, and it introduced a device, of course a fictional device, that was able to transmit messages in a speed that is faster than light. So it is very fast, it is very responsive, and as you're going to see, those are one of the real features of Ansible as a software application that we're going to discuss in this class. It has the features of this fictional device, and hence came the name. Ansible is a configuration management and IT automation tool that was released in 2012 by Michael DeHaan, who was looking for a tool that could combine the roles done by disparate tools: configuration management, server deployment, and sending arbitrary commands to a remote server like through SSH. If you are a system administrator, and I assume you are, you've probably come into situations where you want to run a quick command on a remote system. Let's say, for example, that you wanted to add a new entry to the /etc/hosts file of a dozen Linux servers. You'll probably go to your terminal, type in SSH, or maybe construct a for loop in your shell, and through this for loop you issue SSH commands that will connect to each of these dozen servers and add an entry to the /etc/hosts file. This is just sending an arbitrary command through SSH, and this is done by almost every system administrator I have known to be using Linux or Unix. Ansible does all this without the need to install an agent or open extra ports on your servers. So Ansible, as you have might guess by now, is a configuration management tool. It helps you configure a server, run arbitrary commands on the server, and ensure that the server reaches a required state. A tool that does this is referred to as a configuration management tool, or a CM tool. So I might hear you asking, and what's wrong with plain old shell scripts? Why don't I just use a shell script to do the tasks that I need, to configure the server the way I need it, to ensure that the server or the node is in the state that I require? Well, if you are a veteran system administrator, you will sure be more comfortable with the way you manage your servers using SSH and shell scripts. However, in the era of cloud computing and the need for instant provisioning, shell scripting might fall short when addressing, for example, the following. Of course, the couple of factors that I'm going to list here is just an example or a sample of what shell scripts fall short ahead of in real life, and as you're going to learn about Ansible, and as you will learn later when you examine different DevOps tools, we'll see that configuration management tools do much more than that. But for example, change documentation. While shell scripts allow you to add comments to your commands, this is still far from being a change management document. Change management is very important, and if you are in a medium to large enterprise, you are already aware of the need of change management processes. If you have hundreds of servers, and in the era of virtualization, this is a very, very normal number in a large or medium or even small enterprise. If you are not aware of the changes that are regularly done to those servers, and changes do happen and are required, so if you're not aware of those changes, if you don't document those changes, you might find yourself lost between the different behaviors of servers that are supposed to be identical. For example, if you have like 5 web servers and all of a sudden you discover that one of the servers is not behaving as the rest, let's say that you have, for example, PHP version 5.5 or 5.6 installed on those 5 servers to solve a certain bug that was addressed by this specific version of PHP, and then all of a sudden you find that one of the web servers is still having this bug, and you check on the version of PHP installed only to find that it's an older version than the one installed on the rest of the servers. Let's say, for example, it is 5.4 or 5.3. So you wonder, why is this server having this version of PHP and not the correct version as the rest of the servers? And after some troubleshooting and after some wasted time trying to figure out what has changed, you discovered that you or one of your teams was trying to test something or was trying to make a workaround for some issue that arose on this web server, so he or she decided to downgrade the version of PHP to a lower version, and because this change was not documented, it caused chaos. It caused wasted time and effort, it caused unexpected behavior, it caused losses. So this is one of the needs why a change management policy is required to be in place in each and every organization, no matter how large or small it is. With Ansible and with configuration management tools in general, documentation is inherent, as we're going to see, in the way those tools work, and specifically in Ansible. You're going to see that documentation is part of the instructions file that you're going to work with Ansible. The second factor is something called idempotence. And don't be intimidated by this term, it's just a fancy term that is used to describe the ability of operations to be run multiple times yet yielding the same results. Let's say, for example, that you want to ensure that the Apache web server is installed on the server. This is a requirement that you want to ensure that the web server is installed on all the servers that you manage. So it's as simple as running yum-y install httpd, or if you're running Ubuntu, it may be apt-get install Apache 2. Okay, so it's very easy. Apache web server has been installed. But then a couple of weeks later, you want to ensure that all the servers are having the correct version of Apache web server and that this package was not removed either by accident or deliberately on one of the servers. So you run yum-y install httpdo again or apt-get install Apache 2. However, running yum or apt-get again will do the same steps that was needed to install the package, whether it is already installed or not. It is going to go query the repository sources and grab the version of Apache or HTTPD, and only when it starts installing it, it will discover that a package is already installed, so it will give you a warning or a message that notifies you that this package is already installed. But you needn't go through this. You need a shell script. You need something that tells the script not to go and run the yum tool or the apt-get tool if this package is already installed. You needn't waste time downloading metadata from the repositories or building up the list of packages that is needed for either yum or the apt-get package manager to work if the package is already installed. It has to be just skipped. This step has to be just skipped. So this is called idempotence. You need to run a command, and no matter how many times this command was run, it should produce the same results. And that is exactly what configuration management tools do. As you're going to see later in this class, Ansible and configuration management tools produce scripts that will yield the same results if run either once or thousands of times. It will not run into errors because, for example, it is trying to do something that has been already done before. It should be aware that if something has been already configured, or like for example a package has been already installed, or a file has been already written, or a permission has been already set, it should not try to make this again. It should not try to duplicate this work again. And it should not fall into any errors. This is another thing that shell scripts fall ahead of. Of course, you might argue that shell scripts can have the necessary commands and tools. A clever shell script editor can write commands and perhaps functions that does all those checks automatically for us. But as we're going to see, this makes your script nothing but bigger and harder to maintain. So as you can see here, this is the advantage of using a configuration management tool. So as you can see here, those are just two of the advantages of using a configuration management tool. And as we work in this class with Ansible, you're going to see that it is much more efficient than using a plain shell script. And that brings us to the end of this lecture. In the coming lecture, we are going to start by comparing Ansible to other tools in the market. We might also start installing Ansible on our test machine, so see you next. Hello everyone, welcome back. This is Ahmed again for Idionics, and this is Mastering Ansible. In this section, we are discussing what Ansible is and what a configuration management tool is and why it should be used. In the previous lecture, we have discussed briefly what Ansible is and what DevOps is, and the need for DevOps in the era of virtualization and cloud computing. Let's now see how Ansible is compared to other tools on the market. If you have read about DevOps and configuration management tools, you have sure stumbled upon some other names that fall in the same category as Ansible. You might have heard about Chef, Puppet, or Salt. I'm not going to recommend Ansible over other tools of the same category, as by doing this, I will be misleading you. This is because choosing the right tool for the task at hand is what you need to know. Neither Ansible nor any other tool that's discussed below is a silver bullet. And a silver bullet, if you haven't heard this term before, refers to something that is flawless and suitable for any situation. No configuration management tool, actually no DevOps tool of all the tools that are available for this methodology is a silver bullet. You have to choose the right tool for the right project. Having said that, let's see where Ansible stands among other tools of the same type, like Chef for example. Ansible does not require an agent to be installed on the client, while Chef requires a client to be installed. Chef is tightly coupled with Ruby, Ruby is a programming language just like PHP, but it's often used in configuration management tools like Puppet and Chef, and it's also used for Vagrant. Vagrant will be discussed later in this section, while Ansible uses Python. So if you are comfortable with Python, then Ansible might be a very good choice for you. If you are comfortable with Ruby, I encourage you to continue learning about Ansible, because in my own opinion, Ansible is easier than Chef, and it has a less steeper learning curve. Chef uses JSON format for configuration files, while Ansible uses YAML. YAML will be discussed later in this class. It is just a data serialization format. It is used to store data in a text file on the disk, just like JSON and XML. And some people might argue that YAML is easier than JSON, but that's up to you. We're going to discuss YAML, as we said, later, and you're going to see for yourself which of them is better suited for you. So the choice is yours at the end. No configuration management tool is better than the other, but there is a tool for each task. So you will have to have more than one tool under your belt so that you are prepared for each and every task that you might be handed. So let's have a quick look at Vagrant, because we are going to use this software extensively in this class. If you haven't heard about Vagrant before, Vagrant is one of the DevOps tools that received a lot of attention in the past few years. It works on top of a virtualization platform like VirtualBox or VMware, so Vagrant cannot work by its own. Vagrant is not a virtualization platform. Vagrant is just a tool that works on top of a virtualization platform. So what makes Vagrant different than VirtualBox or VMware, for example? Why aren't we just using VirtualBox or VMware right from the start? This is because Vagrant will ease your life as an administrator or as a developer, because it provides what's called instant provisioning. Instant provisioning means that it saves you a lot of time and effort setting up a virtual machine. Why is that? Because Vagrant uses something called a box. Now, let's say that you want to install CentOS or Ubuntu on your VirtualBox. You go and download the ISO file from ubuntu.com or from centos.org. You download the ISO that reflects the required version of the operating system, and then you create a new virtual machine on your VirtualBox or VMware. You mount the ISO file to the virtual CD-ROM of your machine. You adjust the memory, the CPU, the disk file that it's gonna use, and then you click Start. If you've worked with virtualization before, you are already familiar with what I'm saying. Then you go through the installation process. You configure the packages that need to be installed, you configure the users, you configure the time zone, etc., etc., until at the end you have a bare metal machine ready for you to use. Vagrant gives you a shortcut that saves you all those steps. It's called a box. A box is a ready-made operating system. You have a box for CentOS, a box for Ubuntu, a box for SUSE, a box for Arch Linux, and all major Linux distributions, almost all of them, have at least one box at Vagrant website, which is called Atlas. You can search Google for Vagrant Atlas, and you're gonna see a huge number of boxes that cater to every need. So once you download the box from the website or from any other website, from any location where this box is located, Vagrant can use this box to launch any number of virtual machines. All of them are just ready-made operating system. Once you issue Vagrant up, as we're gonna see in a moment, you have version of the operating system up and running. And this version of the operating system is not just a bare metal version. You can, of course, install the bare metal version, but more often than not, this version contains pre-bundled software. You can, for example, install a Vagrant machine that contains a web server ready installed. You just import the box, issue Vagrant up, and instantly you have a machine that is up and running with a disk already configured, with memory already configured, with CPU already configured, with network devices already configured, with even a username created for you, which is Vagrant, and it also has the Apache web server already installed. So all what you need to do as a developer is just issue Vagrant SSH and you are inside the machine. You can start working right off the bat. You don't have to follow any steps. You don't have to waste any time installing the operating system or setting up the environment by any means. This is just to give you an idea about how Vagrant is a robust DevOps tool. Vagrant uses a text file, and this text file is written in Ruby, so Ruby again is used. It's called Vagrant file, and Vagrant file is just one word, like this Vagrant file with the V capital. This Vagrant file defines the characteristics of the machine, like for example, the host name, the network interface, whether or not it's going to have a private network interface, a NAT, a public network interface, whether or not it's going to be reachable from the outside network, outside the host or not, and many other characteristics of the virtual machine are described or are written inside this Vagrant file. To use Vagrant, you have to download and install VirtualBox or VMware or Parallel. Any of those virtualization platforms are needed or are required to install Vagrant. So in this class, we're going to use VirtualBox. VirtualBox can be downloaded from virtualbox.org/wiki/downloads. Let's have a look at this website. As you can see here, VirtualBox binaries, and as you can see, it supports nearly all operating systems. It supports Windows, Mac OS X, Linux, and Solaris. So you can install VirtualBox on any of these platforms, depending on, of course, the machine that you are using. And once it is installed, it's very easy. Just follow the wizard. And once it's installed, you can install Vagrant. Vagrant can be downloaded from this website, vagrantup.com/downloads. Let's have a look at this website. As you can see here, it's also supported on all major operating systems. It's supported on Windows, Debian, Linux like Ubuntu, CentOS like Red Hat, Fedora, and of course CentOS, and the Mac OS X. So once done, and again, it's just a wizard that you have to follow, and Vagrant is installed. Once it's installed, we are going to create the first machine that we are going to use in the lab, and that will be the starting topic of next lecture. So see you next. Hello everyone, welcome back. This is Ahmed for Avionics, and this is Mastering Ansible. In this lecture, we are going to create our first machine in the lab. Okay, time to create a test machine to be used in our lab. Vagrant works on a pair directory basis. That is, each machine should have a separate directory for it. So let's do just that. I'm going to head to my terminal, and I am in the home directory. I'm going to create a directory. Let's call it, for example, Ansible-machines, just like that. Then get inside Ansible-machines, and Vagrant works in a pair directory basis. On a pair directory basis, this means that this directory where I'm standing here will contain one or more Vagrant machines. But in order to work with those machines, I will have to be working inside this directory. I cannot go to any other directory and issue a Vagrant command unless I am in a directory where a Vagrant machine is installed, or in other words, where a Vagrant file exists. So I'm going to install CentOS 7.3, which is the latest version of CentOS at the time of this recording. And in order to do this, I'm going to issue Vagrant init, and Vagrant init is used to create a Vagrant file for you. Optionally, it can be followed by the name of the box that you want to use. So I'm going to use bento/7.3. And what this command does is that it's going to search for a box that is called bento/centos-7.3. If it finds this box installed on your system, it's going to use it to create a clone, or not a clone, it's a template. It's an instance of this template or of this box, and it is going to create it for you and make it available for you to start logging in and using it. If this box is not installed on your system or is not downloaded already on your system, it is going to head to the Vagrant website, to the Atlas website of Vagrant, and it's going to fetch this machine by name, or this box by its name, download it, and then starts the machine for you. And once it's downloaded, it's going to be used for later instances referring to the same box. So it's going to be downloaded only once and used as many times as you wish. So because I have downloaded this box already before, I'm just going to press enter, and it is going to create the Vagrant file for me. Let's have a look at this Vagrant file. As you can see here, it is well commented. You can see that it contains a lot of characteristics of the machine, like for example the memory. It contains provisioning scripts. We're going to get to that later. It contains the network interfaces that can be configured on this machine, and so on. Let's exit this file now. And the moment I issue Vagrant up, as we said, it's going to either download the box from the remote location if it is not already there, or it is going to use the box that is already on your system if you have downloaded it before, and that is what I did. I downloaded this box already before, so it's just going to use this box to launch an instance of bento/centos-7.3. As you can see here, it is configuring the machine for the network. It's using port 2222 for SSH, and as you know, port 22 by default is used for the SSH connections, but because it is using a NAT network interface, so it does not allow connections directly to the machine. Instead, it allows connections to the host machine on a predefined port, and this port is going to be forwarded to the internal port of the machine. So in our case, if we want to connect to this machine using SSH, we're going to use the port 2222, and this is going to be forwarded automatically to port 22 on the Vagrant machine. It's just a way of securing the machine and preventing outside access to it by default. Now the machine is ready for us to use. Let's clear the screen and let's issue Vagrant SSH. And now we are in. Okay, let's clear the screen, and now we are inside Vagrant. As you can see here, I'm inside. The virtual machine has been created for me with the file systems, with the IP addresses. Everything is just in place. Everything is ready for me as a developer to start working. Now let's exit from this machine, and if you want to, and this is one of the important features of Vagrant, you can issue Vagrant destroy, and this will shut down the machine, as you can see here. Are you sure? Yes, I'm sure. And it will return it to the state it was, and it will delete everything that you have installed or you have changed it in this machine. It will just bring the machine back to the way it was before you made any changes to it. So this is an excellent way to test, for example, new software, or to make any changes to an operating system without fearing of messing up with a production system or with a live system where failure is not tolerated. You can just create a Vagrant machine, do whatever tests you want, and when you're done, you can just issue Vagrant destroy, and this will bring the machine back to the way it was. If I issued again Vagrant up, the machine will be up and running again the way it was before I made any changes to it. But before I do that, I want to make some changes to the Vagrant file. We have seen this Vagrant file, and one of the merits of Vagrant is that it allows you to create more than one machine in the same directory. We have just mentioned before that Vagrant is a pair directory, that Vagrant works on pair directory basis. This means that each and every directory will hold one or more machines. So I'm going to use this directory that is called Ansible-machines to install more than one machine. Specifically, we're going to install a machine that is called client, on which we are going to install Ansible, and another machine that is called server, and this machine will be used as our configuration target. So let's create the client machine. To do that, I'm going to use config.vm.define. This is Ruby syntax, and if you don't know Ruby, that's okay. It's very easy to grasp. So config.vm, sorry, it's config. I wrote it. There's a typo here, so it's config client. Okay, and client.vm.hostname, we're gonna call it client. Okay, and that's it. This is going to create a machine in your directory that is called client. Okay, now let's issue Vagrant up again. As you can see here, it is re-importing the box bento/CentOS-7.3. Okay, so the machine is ready. Let's clear the screen and let's again issue Vagrant SSH. And this time we're going to find that the machine has the host name of client. It's no longer localhost, it has the host name client because we have specified that in the Vagrant file. So as you can see, with a couple of commands, we are able to change the characteristics of the machine. Of course, the host name can be set from inside the machine. This is not a big deal, but I just want to show you how you can change the characteristics of the machine from outside using the Vagrant file. This is going to be very useful when you launch multiple machines, as we're going to see later in this class. So now that our machine is up and running, let's install Ansible. Ansible can be installed in a variety of ways. The easiest one is to install it using the EPEL repository. So let's first install this repository by running rpm-ivh and give it the IP address of the EPEL RPM file. So it's dl.fedora project, and press enter. And now the EPEL repository has been installed. If you're not familiar with this, the EPEL is a repository, and I guess you already know that Linux uses repositories to download and install packages. In Red Hat variants like Fedora, CentOS, and Red Hat, of course, we have the EPEL repository, which contains extra packages that don't ship with the official repositories of the operating system. So If you have a look here at /etc/yum.repos.d, you're gonna find that we have here epel.repo, and this file is the one that is used to, just have a look at the file contents. It's used to download and install extra packages from those URLs, as you can see. So let's clear the screen, and once done, you can install Ansible directly by running yum-y install Ansible, just like that. As you can see here, Ansible has some prerequisites that need to be installed prior to its installation. Most of them are Python related, but Yum is going to take care of all this. It's going to install all the prerequisites and finally install Ansible for you. Okay, now Ansible is installed. Let's clear the screen and let's ensure that we have a successful installation by issuing Ansible -- version on the command line, and as you can see here, it prints the current version of Ansible at the time of this recording, which is 2.3. Some people might prefer to install it using Python pip. If you're not familiar with pip, it is the package manager that is used with Python. If you want to, you can install it using pip, but you'll have to first install the prerequisites. So we're gonna first have to install Python pip like this, Python pip, and once it gets installed, you're gonna have to install the OpenSSL-devel package like this, OpenSSL-devel, and you're gonna also have to install the development tools, because Ansible will need them when you use pip to install it. And once you have those prerequisites installed, you can simply run pip install Ansible, and it's going to install Ansible the same way Yum did. Okay. However, I recommend using Yum and the EPEL repository since it is the easiest way of installing Ansible on a Red Hat system. Now, if you are on a Mac, let's exit this machine by pressing Ctrl-D. If you are on a Mac like me here, you can just use homebrew to install Ansible. You can just type brew install Ansible, and it is going to install Ansible on your machine, and I have already installed it. So as you can see here, it is very easy to be installed either on Linux or on a Mac OS X. If you are running on a Windows machine, I highly recommend that you use Vagrant or VirtualBox, install a version of Linux, Ubuntu or CentOS, and install Ansible on it and use it to manage whatever systems you want, because Ansible, as we said, is agentless. It uses SSH to connect to the servers that you want to configure, so you can just install it on a virtual machine on your host on your Windows and use it to connect to any machine, whether on your local network or even on a remote network on a cloud hosting like, for example, Amazon or Google Cloud or Microsoft Azure or any other cloud provider, because currently Ansible is not supported natively on Windows. Okay, so let's now clear the screen, and let's say that you have an Ubuntu machine. In this class, we are going to use CentOS as our example machine, but I'm going to give you the instructions to install it on Ubuntu. And after that, all the commands that we are going to use in this class can be used equally on CentOS, Ubuntu, or Mac. They are just the same commands. Ansible uses the same commands on all platforms. So I'm going to change directory to the parent directory of Ansible machines. I'm gonna create a new directory, let's call it Ubuntu, and I'm going to use Vagrant again to install an Ubuntu machine. So I'm gonna use Vagrant init, and again I'm gonna use Bento, but this time I'm gonna use Ubuntu-16.10, and this will create the Vagrant file. If I issue Vagrant up, it's gonna use the Ubuntu box that I have already downloaded earlier before I start this class, and it's going to use this box to create an instance of Ubuntu-16.10. Once it is done, I can log into the machine and install Ansible. Okay, the machine is up and running. Let's clear the screen, and I'm going to issue Vagrant SSH to log into the machine. And in order to install Ansible on Ubuntu, you will have to add a repository, just like what we did with the CentOS machine when we added the EPEL repository. We're going to add a repository for Ubuntu that is called Ansible. So in order to do that, we're gonna have to issue apt-get apt-add-repository ppa:/Ansible. Okay, and I'm gonna press enter to confirm adding this repository to my system. And once it is done, let's clear the screen, and I have to issue a apt-get update in order to update the list of sources that I have. It's gonna take a few moments to continue. Okay, now let's clear the screen again, and finally let's issue sudo apt get install Ansible. Okay, I'm pressing yes, and it is going to download and install the prerequisites of Ansible. As you can see again here, it's mostly Python related. Once done, it is going to start installing Ansible. Okay, and it has finished installation. Let's double check that Ansible is installed by running Ansible -- version on the command line, same way we did with CentOS. And it's giving us the same version, 2.3.0.0, which is the current version of Ansible at the time of this recording. Congratulations, you have just installed Ansible on your Ubuntu and on your CentOS machines. Okay, and in the coming lecture, we are going to issue another machine that we're going to call it server, and we are going to issue our first command from Ansible on the client to the server. So see you next. Hello everyone, welcome back. This is a new lecture in your course, Mastering Ansible by Avionics. My name is Ahmed, and in this section we're discussing what Ansible is, how to install it, and we have already covered that in the previous 3 lectures. In this lecture we're going to start actually using Ansible, and we're going to start sending commands to our remote machines. So here we are on our Ansible client machine, where we installed Ansible on a CentOS host, and let's double check that Ansible is installed. Yes, it is installed. But now we need to use Ansible to connect to a remote server and issue commands on this server. For that to work, we will need to have another Vagrant machine in our directory. We need to have another machine, let's call it server, and we're going to use this machine as the target of our Ansible configuration commands. So in order to do this, let's exit from this machine and go again to our Vagrant file, go to the end, and I'm going to clone those 3 lines at the end. Just gonna change client with server, just like this. So instead of client, I have server, and what this is doing is that it's going to create another machine in our directory, and it's gonna call it server. So let's exit this file, and let's issue again Vagrant up. Okay, I have a typo here, I'm sorry, it's server. Okay, now let's clear the screen. Show Vagrant up again. Okay, so it is bringing up a new machine, as you can see, in the same directory. It will be called server. Okay, and once done, let's clear the screen, and let's have a look at an interesting command, Vagrant status. If you issue this command inside a Vagrant directory, it's going to give you the status of the machines that are in this directory. So as you can see here, we have 2 machines. One is called client, the other is called server, and both of them are running. So I can issue Vagrant SSH client to log into the client, or SSH server to log into the server. Let's have a look at the server to ensure that it's up and running as we require. Okay, as you can see, Vagrant at server, it is running with the correct host name. Let's exit, and because we are going to use Ansible to connect from one machine to another, both of those machines need to have external IP addresses, at least to be connected to each other. Because currently, if I log into the server, as you can see here, and I issue IP ADDR, you're gonna see here that I have an IP address of 10.0.2.15. This is a private IP address. This is not reachable from the outside network, even from other VM machines on the network. If I issue Control D and I go to client and I issue the same command IP ADDR, I'm gonna see that it's having the same IP 10.0.2.15. It's the same IP address that has been used here. And this is natural because this is hidden from the outside network. This is a NATed IP address. So no wonder that both of them are using the same IP address, because both of these are not reachable from the outside. But I don't want this behavior. I want a second interface on this machine, because this first interface must be set by Vagrant. I need a second interface here that should be used by the machines to connect to each other. So let's exit. And let's go to Vagrant file. I'm doing this just to show you how easy it is to use Vagrant, how small changes to the Vagrant file can dramatically change the behavior of your Vagrant machine, and it's all a matter of seconds before the machine reflects your changes. So what I'm going to do now is that I'm going to copy this line, which defines the network, config.vm.network, which is the private network. I'm going to paste it on each one of them. But of course, after doing the required changes, just change config with client, and let's leave this IP the way it is. Let's paste this line here and replace client here with server. And let's change the IP address, of course, to reflect another IP address. Let's call it 20. So now I have two machines. Each of them is having a different host name. Each of them is having an extra network interface card connected to private network between them, between each other and the host. So this network is reachable from the host, the Mac, and it's also reachable from those machines, but it's not reachable from the outside network. Outside of this host, these IP addresses are not reachable. They are host-only or private network IP addresses. Let's exit the file and clear the screen. And in order to reflect those changes, all that you have to do is issue vagrant reload, just like that. And vagrant reload will reboot both of those machines, and it will ensure that all the changes that have been made to the vagrant file are reflected to the machines. So I'm expecting now to log into each of the machines and find an external network interface card inserted with the appropriate IP address set. Okay, now the machines are up and running. Let's clear the screen. And if we log into client and issue IP ADDR, you're gonna see that I have a new IP address added here in another or a third network interface. We have a loopback interface, the NATed interface that has to be there, and then our extra network interface card that we have created using the vagrant file, and it is bearing the correct IP address 192.168.33.10. And if we log into the second machine of the server, we're going to find the same result here, but with a different IP address, which is 33.20. If we try to ping 192.168.33.20, it should reply. It is replying. This means that both machines are now reachable through this private network. So let's clear the screen and let's now prepare to run our first Ansible command. If you want to run an Ansible command, you will first have to explore the Ansible hosts file. The Ansible hosts file is the inventory file of Ansible. It is the file that contains the hosts or the machines or the nodes, if you wish to call them, that you want to configure or that you want to target with your Ansible commands. By default, this file is located inside /etc/ansible/hosts. If this file is not there, just create the directory, and if this file is not created during the installation, just create it by hand. Now, if you have, it's sudo vim or vi, vim is not installed yet. If you have a look at this file, it is well commented, and it gives you actually a lot of information about its structure. So in this file, you can have the hosts either one per line, the host name or the IP address, as you can see here, green.example.com or blue.example.com, or just an IP address. So this just depends on whether you can connect to the machine using its host name or using its IP address. They're just gonna be written here. Or you can group hosts by adding the name of the group in square brackets like this. So we have here web servers, for example, and we have here 4 servers that are supposed to be web servers because they are under the group of web servers. So they're either grouped or ungrouped. And you can also have ranges of machines using this shortcut. So let's say, for example, that you have 6 machines that start with www.001.example.com, 002.example.com, and all the way up to 006.example.com. So instead of writing 6 lines of machines starting with www.001.example.com and moving all the way down to 006, you can have this shortcut. This range, will instruct Ansible that it has 6 machines starting from www.001 all the way to 006.example.com. And this is the third example, as you can see. It uses a group that is called DB servers and so on and so forth. Let's create a group at the end of the file. Let's call this group servers. I know this name is very generic. It's just for the sake of an example. Let's add the IP address of our server, our only server in the network, which is 192.168.33.20. That's it. Let's exit the file, and now you're ready to talk to this server using Ansible by referring to its group. So communicating with the server using Ansible is as easy as issuing the Ansible command like this. Ansible, then the name of the group, which is servers. Then you have several switches that you can use with Ansible. In this example, we are going to just send an arbitrary command which can be done by having a -a flag or option, followed by the command itself. So let's say, for example, that I want to cat/etc/hosts. I want to display the contents of /etc/hosts of all the servers. In this example, we only have one server or one node in the group that is called servers, so it is supposed to display the contents of just one server, which is the one that we have in our environment. Pressing enter, it's going to connect to the server. As you can see here, it's connecting using SSH. I'm gonna press yes. Okay, and as you can see here, it's giving me a failure message, failed to connect to host via SSH. And that is because it uses public-private key for connection. And as a matter of fact, this is the way most cloud provisioning vendors use to let their clients connect to their machines. You have to use a public-private key authentication. In order to do this, it's as simple as issuing sh-key gen command, just like this, optionally -t RSA to specify the key type, which is RSA. Pressing enter, I'm gonna leave it without any passphrase, so it's gonna be empty. And this has created a private key in this path /home/vagrant/ssh/id.rsa. And also it has created a public key in the same path, but under name id_rsa.pub. This is the key that I want to copy. So I'm going to cat this file, just like this. It's going to give me this group of strings, numbers, and special characters. I'm just going to copy it the way it is from the start to end. I'm going to exit this machine. I'm going to issue Vagrant SSH server to log into the server. Okay, now I'm inside server machine. Let's clear the screen. And what I'm going to do is that I'm going to go to .ssh in the home directory, and I'm going to edit a file that is called authorized keys or authorized_keys. This is the file that contains the keys that are authorized to log into this server without entering a password, just by using the key. And I'm going to go to the end of the file, and I'm going to paste the public key that I have just copied from the client machine. Now I exit this file, saving it, exit the machine, and return back to client. And if you want to double check your work, and you should before using Ansible, I can just try login to this machine using SSH. And if everything works correctly, it shouldn't ask me for a password. Pressing enter, as you can see here, I have logged in directly to server without being asked for a password. Now let's exit, and again let's run the command that has failed before, which is Ansible servers -a, then give it the command cat/etc/hosts. This time the command has run successfully. It is giving you here the statistics of the command first. This is the only host that we have in the servers group, 192.168.33.20. It is informing you that it has successfully connected to the server, and it is displaying the contents of /etc/hosts. As you can see here, it contained nothing of importance. Let's add something that is a little unique to this machine in order to display it. So let's go to /etc/hosts, and let's add the IP address of the client. Just should use sudo for this because this is a protected file. So I'm going to write down the IP address of client 192.168.33.10, and I'm going to name it client. Now exit this machine and log in back to SSH client, run the same command, and you should see that it is grabbing the additional entry that we have added to the server, which is the entry for the client. So congratulations again, you have just issued your first Ansible command. And that brings us to the end of this lecture and to the end of this section. In the coming section, we are going to discuss how you can integrate Ansible with Vagrant to bootstrap machines and automatically provision it using Ansible. So see you next. Hello everyone, welcome back. This is section 2 of your course Mastering Ansible by Avionics. My name is Ahmed, and in this section we are going to use Ansible with Vagrant for fast provisioning, or for instant provisioning as it is sometimes called. So let's get started. So in the last section we introduced Vagrant as a provisioning platform that works on top of a virtualization platform like VirtualBox in our example. And you saw how easy it was to fire up multiple machines at the same time, change the network configuration, and so on without having to go into time-consuming details of VirtualBox or VMware. Just by making some changes to the Vagrant file, reloading the machines, all the changes are reflected immediately to the machines that you control. Additionally, and as a provisioning platform of its own, Vagrant can be integrated with configuration management tools like Chef, Puppet, Salt, and of course, Ansible. Let's have a look at how we can integrate Vagrant in order to provision a machine and use Ansible to install necessary software on this machine as part of its configuration. So, let's have a look at our example system, okay, and let's exit from our previous lab that we used in the last section. Let's clear the screen and let's create a new machine for our example here. Let's go to Vagrant file, and as we have learned in the previous section, we can create more than one machine in the same directory using one Vagrant file, and this can save you a lot of time and effort. So what we're going to do is that we are going to clone or copy those 4 lines. We don't need to have a private network for this machine, just we need to change its name. Let's call it web server. Okay, so it's web server as the variable, and here it's going to be called web server and web server. Okay, so now we have a new machine that's going to be created when the Vagrant up is used. But now let's add something new to this configuration stanza. Web server dot vm dot provision, and this part of the Vagrant file allows you to choose among multiple provisioning platforms or multiple provisioning tools, as we said, Chef, Puppet, Ansible, Salt, and other configuration management tools. We are going to use Ansible and do Ansible playbook. I'm going to discuss what a playbook is in a moment. It's going to be called myplaybook.yml for YAML. And we are going to end this stanza. Okay, this is the new part that I've added to this stanza. This is the provisioning part. I've used Ansible as my provisioning platform, and I've just instructed Ansible inside the Vagrant file to use a playbook that is called myplaybook.yml. Now, let's exit this file and let's discuss what a playbook is. A playbook is a file written in YAML, and YAML is the language that is used by, not the language, it is the format that is used by Ansible to store the instructions that it is going to follow when configuring servers. The file is written in the YAML format. So if we want to understand how the file works, we will have to understand what YAML format is. YAML stands for YAML Ain't Markup Language. It's just written like this, YAML Ain't Markup Language. Yes, it is one of those recursive acronyms, just like PHP, Hypertext Preprocessor, or GNU, not Unix, and so on and so forth. Some open source or a lot of open source terms are constructed that way. It's just the first letter of the acronym is the acronym itself, so it's recursive. Anyway, it's an international format that is used for data serialization, and you can think of it as the counterpart of JSON. Some people claim that YAML is easier than JSON. It's up to you. I'm going to show you a document written in YAML, and I'm going to show you how this document can be written in JSON, and you will see the difference, and you can decide which of them is better or is easier. However, in all cases, Ansible uses YAML as its format of choice. So let's see an example YAML document, and for this I'm going to use TextMate to give you a better view. Okay, so here I am in the Ansible machines, and let's create a new file that is called myplaybook.yml, which is the YAML file. Okay, so the YAML file can optionally start with triple dashes like this, and it can optionally end with triple dots like this. Between those, I can start writing the document. A YAML document consists of key value pairs. Let's say, for example, I have name, and this is the key. I want to give a value for this key, so I'm going to place a column like this, and a space, and then I can write whatever name I want. Let's say Ahmed, for example. I can give a job. This is another key, Linux engineer, for example. Okay, And I can also add a list or an array or a dictionary or a hash, whatever term you wish to call it, just do, because I know this is a source of confusion for many people, because they don't understand the difference between YAML and JSON, and they don't understand the concept of dictionaries. So if you want to call them arrays like they are called in JSON, it's okay. They are called dictionaries in YAML, but both of them refer to the same concept. I can have here, like for example, skills, and I want to mention multiple skills for this person or for this record. So I am going to add a colon, and this time I'm not going to add a value. I'm going to add multiple values. So to do this, I'm going to have a new line, start a new line with a dash, and I can add either name value pairs or just values. So I can say C#, Python, PHP, for example. Okay, so I can also add a key value pair of its own, like for example, scripts. I can add bash, for example. Or I can further nest this list like this, scripts. I can add bash, corn, zsh, for example. So this is basically how a YAML document is formatted. And you can use codes if you have to enter invalid characters, for example, not invalid. If you want to enter special characters, like for example the sh, this is the best, okay? And let's say that I want this to be inside, let's say that I want to add this inside the value. I want to add a colon inside the value. So this won't work because a colon is a special character in YAML, so I'll have to quote it with double quotes like this. This way I can ensure that YAML will not complain of this colon being placed inside the file. So now that you know what a YAML format is, we are ready to start writing the myplaybook.yml. We're gonna replace the text in this file with the instructions that Ansible is going to use to configure the web server machine that we have just defined in the Vagrant file. That will be the starting topic of next lecture, so see you next. Hello everyone, welcome back. This is a new lecture in your course, Mastering Ansible by Avionics. My name is Ahmed, and in this section we are discussing how Vagrant can be integrated with Ansible as a provisioning tool in order to create a machine that is automatically configured using Ansible. In the previous lecture, we have discussed the playbook, that is the file that contains the instructions for Ansible to work, and we mentioned that this file is written in YAML, and we briefly discussed YAML as a language or as a data serialization method. We have seen how we can write a basic YAML file. Now it's time to start writing our YAML file, myplaybook.yml. So here we are on our TextMate. Let's delete all this and let's start writing the real stuff. Let's start writing the instructions that is going to be used with Ansible. So the first line, we are going to write hosts. This is the key, and it's going to be all. And as you can see here, we are starting with a dash. This means that this is part of an array or part of a list, but this list does not have a name, and that's okay. That's the way this playbook starts. And hosts is instructing Ansible that it is going to run this playbook on all the hosts that are configured in the Ansible hosts file. And you might think, where is the Ansible hosts file? This hosts file in this case is used internally by Vagrant, and it is not visible to us. Vagrant will use it to address the machine that it's configured to use Ansible to configure. In our case, it's web server. So I'm here instructing Ansible that it's going to use this playbook on all the hosts that Vagrant will use. That is because we are not going to edit or to view the file used by Vagrant. This is used internally by Vagrant. So we are just instructing Ansible to use any host that happens to be defined in this file. And of course, in our case, it's just one server, which is the web server. Now, the second line is become. I'm gonna give it the value of yes. And notice here that I am using indentation to match this key value with this one. Indentation is very important in YAML. All items that are on the same level of indentation are grouped together. This might seem vague at first, and don't be intimidated. I'm gonna give you at the end of this file, I'm gonna give you the counterpart of this file in JSON, so that if you are more familiar with JSON, you'll get an idea about what's going on here. Just understand for now that indentation is very important and you are not allowed to use tabs in YAML. If you use tabs, the format is going to be broken and Ansible will give you an error message. So you have to use spaces, and you have to use spaces so that similar items are grouped together with the same indentation level. So here I am interested in grouping those together. We're gonna see that when we convert this file to JSON format. Now, the next key is tasks, and this is going to be an array or a dictionary or a hash or list if you wish to call it. And as we have just mentioned, lists or arrays in YAML list items start with a dash followed by a space. Each task should have a name. Let's give this task the name of ensure that Apache web server is installed. Then we're going to give it the module that it's going to work with. Notice here that I am not adding another list item. I am putting this in the same group as the name. I'm putting it in the same indentation level. Again, this might be more intuitive to you when I convert it to JSON. So I'm going to use yum, and yum here is the module used by Ansible to use the yum command on the operating system. It contains several parameters that can be used to instruct yum to do whatever task needed on the server, like to install or deinstall packages. The value is name. The name is HTTPD, which is the name of the package that we need to install. We need to install a web server on the web server machine, and our web server is called Apache, and the name of the package in the YAML repository is called HTTPD, which is what we're doing. Then we can have it. Then we have to give it the state. The state is either present or absent. Present means I need this package to be installed on the system. As you can see here, the file is self-documented. As you have a look, I have a name that includes the description of the item, and I also have self-explanatory parameters. So the name is the name of the package, and the state is the state that I need this package to be at when the server is configured. So I want Ansible to ensure that HTTPD is installed on the system. If it is already installed, just pass on this step, then do nothing. If it is not installed, go and install it using yum. So I can replace this with absent if I want to, and this will ensure that HTTPD package is not installed in the system. If it is installed, just go and uninstall it. If it is not already installed, just go ahead to the next task. So I'm going to ensure that the HTTPD is present. And notice here how I used the name equals value in the value field of yum. I can use this the same way as this. Name HTTPD and state is present. It's just a simpler way, or it uses less space when I put it on the same line. But let's leave it like that to be more readable to you. And now I'm going to add another task. So I'll have to be at the same indentation level as name, the previous name. And again, the next task is to ensure that the service is running and persistent. Persistent here means that I need the service to survive reboots. When the server gets rebooted, I need the server to start automatically. So I'm going to add service at the same indentation level, HTTPD, name equals HTTPD. Let's use the shorthand notation here, and state is started. I'm instructing Ansible to start this server, to start this service if it is not already started. If it is already started, then this phrase or this command is going to be just ignored. And enabled is yes. This means that this service needs to be persistent across reboots. When the system gets booted, this service needs to be started. Okay, let's save this file, and I'm gonna quickly give you the counterpart of this command in JSON. Okay, so this is the counterpart JSON file of this myplaybook.yml or .yaml. Okay, so let's have a quick look at the difference between both. So as you can see here, because I started this hosts file, or because I started this hosts with a dash, this means that this item is supposed to be a part of an array. So here, JSON is starting with an array, and this array does have only one item. That is because all the other items in this YAML file are at the same identation level as hosts. So this means that this is only one item in the array that has no name. I have no name for this array, so it's just an empty array, as I can see here in the JSON file. Okay, can just get it here, and it's gonna be more visible, I wish. Okay, now you have become, yes, this is another key value at the same indentation level. It's another key value pair in the item tasks, and the tasks refer to an array. That is because I have the items that are under tasks added to have a dash and a space before it. So I have a name and then yum, and because yum did not start with a dash, this means that it is another key value pair inside the tasks. So this task contains two items. The first item contains a name and a yum parameter, and the yum in itself contains other parameters, name and state, as you can see here. And this is because we used the long way of adding the parameters or of adding the items to yum. If we use the short way, like name equals httpd, like here, it's just gonna be added like this inside the value, inside the quotes, like this. But because we used the long version, so it has been written like this, a name and a value, just like that. So this is an item, or this is a task, and this is another task, name and service. Okay, so both of them are present in the documentation that accompanies this lecture. You're gonna see for yourself the difference between YAML and JSON. Some people argue that this format is easier. Some others argue that this format is more readable and is easier and it's shorter, as you can see. It's up to you. However, you will have to, in all cases, be aware of the way YAML handles data, because it's gonna be used in Ansible, and Ansible is going to parse this playbook file to actually start working with the machine. And that brings us to the end of this lecture. At the start of next lecture, we are going to bootstrap the machine. We're going to see how Ansible uses the playbook to configure this machine and to install the HTTPD server and to ensure that the web server will be up and running when the machine boots. So until then, see you next. Alright, hello everyone, welcome back. This is a new lecture in your course Mastering Ansible by Avionics. My name is Ahmed, and in this section we are integrating Vagrant with Ansible. We are going to bootstrap a test machine that we called it web server, and this test machine will already have Ansible attached to it. It is going to configure the machine the moment it starts by utilizing this myplaybook.yml playbook. And as we have mentioned before, a playbook in Ansible is the file that is written in the YAML serialization language, and it follows the instructions that are written in this file in the YAML format to start actually configuring the server. In this file, just to refresh your memory, we had two tasks. The first one is to install HTTPD service if it is not already installed, and the second is to ensure that this service is up and running, to start it if it's stopped, and to ensure that it gets started every time the system boots. So now everything is in place. Let's go to our terminal, and we are inside Ansible-machines. All what I'm going to do now is that we are going to issue Vagrant up in order to boot up the web server machine. Now observe what's happening here. It's running provisioner Ansible, running Ansible-playbook. So now Ansible is running. As you can see here, it is typing in the name of the task, ensure that Apache Web Server is installed, and it's actually running this task on the machine. Okay, now Ansible has finished and the machine is bootstrapped. Let's have a look at the output that Ansible has written for us. Task, ensure that Apache Web Server is installed, change it web server. And this is the name of the machine or a group that Vagrant has used, and as we mentioned, it only has one machine, so it's web server. And also the task to ensure that service is running and persistent. This means that it's gonna start the service if it has not started, and it will ensure that it gets started whenever the system boots. Play recap, this is the final statistics. OK 3, change it to unreachable 0. This means that if any of the servers were unreachable when the Ansible runs, it will state here that unreachable is 1 or 2 or 3 or 0 if none were unreachable, and failed 0. This means that everything ran correctly. Now let's double check that everything is really in order, so let's clear the screen and let's issue Vagrant SSH web server. to log in inside the web server. Okay, now we need to ensure that HTTPD is installed. This can be done by actually running rpm-qa. Then you can grab the package HTTPD. As you can see here, we have HTTPD tools, which is a helper package, and the HTTPD itself, which is the Apache web server 2.4.6-45, which is the latest version at the time of this recording, is installed, and it has been installed automatically when the machine bootstrapped, when the machine was created. Now let's have a look at systemctl status HTTPD, and as you can see here, it is started, it is active. And if you have a look at check config -- list grep HTTPD, in our case, well, we are in CentOS 7, so I'll have to use systemctl is -enabled HTTPD. And yes, it is enabled. This means that it is going to be started as soon as the system boots. Congratulations, we have just used your first playbook on Ansible. But now I guess you might have an important question. What's wrong with a shell script? I could have just done the same thing using a shell script. I could have just logged into the server, or even from the outside of the machine. Let's log out, and I can use something like this: SSH-B2203, which is the port used by my local host to connect to the Vagrant machine, because as we said, it is on a netted network. And I can just run yum-y install HTTPD, and then I can run systemctl enable HTTPD. I could have just used that, right? That's okay, and you can sure use that to install HTTPD service and ensure that this service is up and running on system boot. And as a matter of fact, Vagrant supports shell scripts as a provisioning method, just like Ansible Puppet. If you have a look at the Vagrant file, you can see that at the end of this file, we have an example of how you can use a provisioning method, which is the shell. As you can see here, it's giving you just here an example: apt-get update, apt-get install -y apache 2. So you can use actually the shell as a form of provisioning inside the Vagrant file, and it's going to work the same way as Ansible. However, Ansible in particular and configuration management tools in general have, as we said, much more advantage over using shell scripts. And let's see a practical example. Now let's log into the server again. Let's clear the screen in Vagrant SSH web server. Now, as we have mentioned in the first part of this class, in the first section, which is that configuration management scripts or configuration management tools must be idempotent. And we said that idempotence means that if we run a command several times or once, it should produce the same result. This means that I must be sure that the HTTPD package is not installed before attempting to use yum or apt-get, if you are using Ubuntu, to install it again. You might argue, yes, that's easy. I can write a command like this: if not rpm-qa and grep HTTPD, which means that if HTTPD is not installed, and let's just direct the output to /dev/null so as not to clutter the screen, and I can say then and echo installing HTTPD. I'm just pretending that I'm installing HTTPD, so I could just replace this with yum-y install HTTPD. Okay, then fy, and then fi. Okay, and because HTTPD is installed, this won't work. So what if I deinstalled HTTPD and use the same command again? Sudo, okay. If I use the same command again, it's not going to install it. Guess why? Let's run rpm-qa grep HTTPD. And although we have removed HTTPD package, one of its helper packages is still there, httpd-tools. And that's why this command is failing. That's why it's not installing HTTPD, because when it ran the grep command on HTTPD, it found that there is actually a package that has HTTPD in its name. So it considered that HTTPD package is installed, and accordingly it did not install HTTPD. Okay, you might argue that, okay, that is easy. We can just add grep HTTPD and then also grep -v HTTPD-tools. This will ensure that even if HTTPD-tools is installed, it will consider that Apache Web Server is not installed, and it will attempt to install it. As you can see here, installing HTTPD. It's going to use the yum command to install HTTPD. But look at the script. Look how long the command is, and look how hard it is to maintain. And imagine that you have more than one command, and imagine that you have more than one package that has this string HTTPD inside. Imagine that you have more than one server, and each one of them is having different packages. Perhaps one or two of them is using HTTPD in their name. So how can you write a generic script or a master script that should be run on each and every server or each and every host name in your list, and it's going to account for different packages that may or may not have the string HTTPD in its name, so that this grep command should not fail? So as you can see here, the script is starting to get more and more complex, and this is just only for one task. Imagine the rest of the tasks that you want to perform on the server. Imagine the one that is checking for whether or not the service is running, and if it's not running, to start it, and if it is already started, just ignore. You'll have to write if conditions everywhere on your script, and you have to heavily comment your script to be readable. Additionally, you will have to inform the user of what's happening. If you remember from, let's have a look here. If you remember from our Ansible run, Ansible was writing down the name of the task as it is doing this. So task ensure that Apache Web Server is installed. This is the task that is being run. So perhaps you might want to do this. Echo installing HTTPD, then followed by yum-y install HTTPD, like this. So installing HTTPD, okay, I need to be root. So let's sudo -i, but just give you a real world example. Okay, so you will have to write installing HTTPD, and then it's going to give you the details of how yum is working. Maybe you want to hide this from the user. Maybe you just want the user to see the tasks that are running just as a list of items, and behind the scenes, yum is working to install the package. So as you can see here, using shell scripts is starting to get more and more complex, and this is only for simple tasks. When we get to more complex tasks and more complex templates, when you configure non-trivial packages on the system and having to deal with configuration files and so on and so forth, you're gonna see that shell scripts are not the best choice, or not the best option when you are dealing with multiple servers, when you are dealing with complex scenarios. So I hope now you have seen how Ansible and configuration management tools are so powerful in automating your infrastructure when used in conjunction with other provisioning services like Vagrant, to bootstrap machines on the fly with all prerequisites installed automatically when the machine boots, and with the minimal code writing, and also with the most human-readable format. In the coming sections, we are gonna delve more and more into Ansible, and we're gonna slowly dive deeper into more complex scenarios where Ansible is going to prove itself as one of the best configuration management tools that you can use in today's DevOps world. That brings us to the end of this lecture and to the end of this section in Mastering Ansible by Avionics. My name is Ahmed, and see you next.